All right, today we are diving deep. I mean, really deep. We're on a quest to find the absolute smallest, most fundamental building blocks of everything.
But before we get into all that, just take a look at this. It's a photo of the sun. Simple enough, right? Except, this picture was taken at night, and not by looking up at the sky, but by pointing a camera down, straight through the Earth, to see the sun on the other side. Wild, I know.
Okay, so how is that even possible? I mean, what kind of particle can just zip through the entire planet like it's not even there and still make a picture? Well, the answer to that puzzle is exactly what we're talking about today. It's all in the bizarre, fascinating world of fundamental particles.
So to really get a handle on this, we've got to peel back the layers of the good old atom. We're going to go way beyond that model you probably remember from your high school science class.
You all know this picture, right? It's classic. You've got this tiny, dense nucleus in the middle with positive protons and neutral neutrons, and then you've got these negative electrons just buzzing around it. For the longest time, science thought that was pretty much it. Protons, neutrons, electrons, the end of the line.
But what if that picture isn't the whole story? What if some of those particles we thought were the end of the line aren't actually fundamental at all?
So in physics, there's a really important distinction. On one side, you have fundamental particles. Think of these as the ultimate indivisible Lego bricks. You just can't break them down any further. Then, on the other side, you have composite particles. These are more like things you build with the Legos. They're made of other, smaller pieces.
And here's the big reveal, the huge twist. Protons and neutrons, the very heart of every atom, are composite particles. They're actually made of something smaller.
Okay, so this discovery blows the doors open to a whole new family of particles. Protons and neutrons, it turns out, belong to this big club called the Hadrons.
So what does it take to be a hadron? Well, two main things. First, they feel what's called the strong nuclear force. That's the super powerful glue that holds the nucleus of an atom together. And second, they're all made of even smaller, truly fundamental particles called quarks.
Now, this hadron family has a couple of main branches. You've got the baryons, that's where our friends the protons and neutrons live, and they're always made of a team of 3 quarks. Then you have the mesons, which are a bit more exotic. They're made from 1 quark and 1 antiquark. Yep, that's matter's mysterious opposite twin.
Okay, so if hadrons are made of quarks, that begs the question, right? What in the world are these quarks? Well, let's meet the real superstars of this whole subatomic show.
You know, the recipe for these guys is actually surprisingly simple. A proton, it's just 2 up quarks and 1 down quark. That's it. Now, if you swap 1 of each, you get a neutron. 1 up and 2 downs. I mean, just stop and think about that for a second. Different combinations of just 2 tiny ingredients create the core of literally every single atom in the entire universe. That's incredible.
And this is where things get really weird, in the best way possible. Quarks have fractional electrical charges. An up quark has a charge of +2/3, and a down quark has -1/3. Before we discovered quarks, no one had ever seen a particle with a charge that wasn't a nice, simple whole number.
And those weird fractional charges are so important. Come on, let's do the math real quick. For a proton, remember 2 ups and a down, you get +2/3 plus another 2/3 plus a -1/3. And what does that equal? Exactly +1. It's perfect. Now for the neutron, 1 up and 2 downs, that's +2/3 -1/3 and minus another 1/3, which adds up to a nice, neat 0. See? The quark math just perfectly explains the charges we've always known for protons and neutrons. It all fits.
Okay, so we've got quarks, and they build hadrons. Awesome. But what about the electron? Where does it fit in? It's definitely not a hadron. Well, it belongs to the other great family of matter, the elusive leptons.
You can think of leptons as the loners of the particle world. Unlike the hadrons, they are truly fundamental. They aren't made of quarks or anything else. And this is the key difference. They don't feel that strong nuclear force at all. That means they don't get glued into the nucleus like protons and neutrons do.
So the most famous lepton is, of course, the electron. We all know that one. But there's another member of this family that is way more mysterious, the neutrino. This thing has almost no mass, it has no charge, and it basically doesn't interact with anything. It's like a tiny subatomic ghost.
And that brings us all the way back to that impossible photograph from the beginning. Remember it? The picture of the sun taken through the Earth? It wasn't taken with light, it was taken with neutrinos.
And it all makes sense now, right? Because neutrinos or leptons, they completely ignore that strong force. And because they have no charge, they don't care about electromagnetism either. So they can just fly straight through solid matter like it's empty space. In fact, trillions of them are passing through you right this second, and you don't feel a thing. They can pass through the entire planet, which is exactly how you can take a picture of the sun at night.
So, let's take a step back. We have hadrons, which are made of quarks, and we have leptons, like electrons and neutrinos. So how does this all fit together? Well, it actually gives us this incredibly beautiful unified picture of all of matter.
Okay, let's put it all together in what we call the Standard Model. It's pretty simple, actually. Everything we've talked about that builds stuff, the quarks and the leptons, they all belong to a group called fermions. They're the matter particles. Then you have another group called bosons. These guys are the force carriers. A photon carries light, a gluon carries the strong force that holds quarks together. And that's basically it. All of reality is just built from these two types of particles, the builders and the force carriers.
It is just an incredible thought, isn't it? Everything you see around you, everything that you are, it's all just different arrangements of a handful of quarks and leptons interacting with each other through a few basic forces. It really makes you wonder, what other secrets of the universe are these tiny, fundamental particles just waiting for us to unlock?